Hey there guys, and welcome back, and today we will be doing a controller. I'm thinking palm held controller, joystick for the arcade prototype deal, setup, rig, whatever you want to call it. Forgot to grab a pen. So this is basically how I've been thinking of it going is, and I do have the camera on the left hand side this time. It turns out that the image is not nearly as bad with these extra lights I've installed, and I adjusted the brightness so that I'm not completely whitewashed, so that all turned out great. So glad we were able to fix that issue. Now you can see as I'm writing, because I write right-handed. I am not in fact flipping the camera in real time to make it look like I am right-handed. So sorry, clearing my throat a little bit. Basically a joystick, as far as I've researched, is an axis on a flat plane. And as it turns out, they actually use the same exact centering mechanism that I was going to use originally in the Muse Dash left-right controller, which is a spring. So the spring is just down here, and it's one of those things when the axis goes off center, the spring wants to recenter it because it wants to extend all the way out. So it's a compression spring. It wants to go back to neutral, and therefore neutral will be the longest distance being straight up and down. So we will design around this basic format, and then for the general design, again, I want to do a palm shaped, so a half dome shaped controller. One of those things, palm shaped, is not quite perfectly circular, right? We'll deal with that as we get there. And that will just go on top of this axis. One of those things, it will just look from here down like a regular old joystick axis with the micro switches around the corners here. And I will be going with micro switches as opposed to an analog input, just because, again, as it turns out, arcade sticks use micro switches, and I would like to keep with that. So anything else to say? Oh yeah, buttons. I do want to have some buttons built into the control itself. I've been thinking about it, and thumb obviously makes sense. Thumb button makes sense. Two buttons here, left, right click, makes sense. I don't think it makes sense to have either of these two. One of those things, this guy, a button on this finger can be a little tricky depending on the shape of the thing. So for example, if I make it full palm shaped like this, you can see how this button going on the corner here, it's kind of awkward to hit depending on how that lines up. It kind of, my finger doesn't really want to go in that direction. Plus, one of those things, just basic tendons, these two tendons aren't together, so you're more inclined to click both of these at the same time. And for the pinky, depending on how round we have this, the pinky is going to be in at a weird angle, so I'll leave the pinky off. So we'll just have three buttons: right click, left click, or left click, right click rather, and then the thumb button. I also toyed with the idea of having a 3-axis controller, but I think that's a little ambitious at the moment. Maybe we come back and add that later on, but 3-axis is probably more than I'm looking to engage in at the moment. So that is the plan. Not much drawing today because it's all very straightforward, all stuff we've seen before. One thing which I did not bring up, which I will bring up now, my research, because I did not have a great idea of how exactly. I mean, obviously, from the first time, from when we did the first setup of the prototype, I did not have a great idea initially of how a joystick worked. Again, I assumed it was analog, just like everything else. And by everything else, I mean just like a game console controller, and that is evidently not correct. Also, I am glad I am previewing this because that is not the window I was looking for. Okay, cool. So let's swap you out to, let's see if I can find this one. I just wanted to get this page up. There it is. All right, cool. And push live. So I did come across this page, which was very useful, and it's a slide coin joystick page. And Not this one. Let's see. Joystick components. There we go. I was looking for a breakdown of what it all came, how it all was set up. So I was very happy to find this page, confirming everything for me on how it set up, and therefore I'm just plugging it, I guess. Also, this is interesting. This was how I assumed, because it's one of those things, as you move a joystick, you're sweeping out a hemisphere, basically. Well, you're sweeping out a circle more than anything, but depending on how exactly it pivots, it could be a hemisphere. So I was expecting a round shape like this half hemisphere. Well, not half hemisphere is redundant, but a hemisphere shaped pivot point is what I was expecting, because that made sense to me. But evidently they also make them with these cylinder ones, and I don't exactly know how that works, so that's pretty interesting to find out. Otherwise, like I said, it turns out that they're built more or less with the springs how I just assumed it was naturally built, which I was quite happy about. So anyway, just wanted to throw that page out there just because I found it, I was very happy to have something to just confirm what I was thinking. So let's hop back to Fusion. Fusion, because I have to capture the full screen, is full screen, so I gotta actually minimize the other window. Alrighty, so as you can see, I already just got the basic stuff up in here. You should be well familiar with this if you watched all the other segments of this series. The prototype controller obviously is built off of these 2020s, so we just got that in here. I've got, I believe, some parameters brought in naturally. Let's check. No, not really. Never mind, I take it back. So don't actually have parameters, but we don't really need them. So we will go ahead and get to building. And I believe 30 millimeters is my height. Let me check that really quick, actually. Let's open up a previous one. Well, we'll open up a couple of them just because I think there might be some variants, but I'm not 100% sure. 3-inch button. What's the top of this guy right here? Or that two, rather. That right there. Okay, that's 45. Just to get a baseline height of what I had these guys at, 44. So actually about 45 it looks like. Let's check the Mustache controller. Top of that to that, 47-ish. Okay, so yeah, around about 45 is where I'm starting at. Maybe this is 30 right here. I don't know. Actually, you know what? I should. I can. It's easy enough to check that, so may as well check it. That's 27. Don't save. Inspect. 30. Maybe that's where I got the 30 from then. Maybe the bottom of the button is 30. 28. Alright. Probably just rounding in my head. So we'll just stick with this 30 then. Yeah, we'll stick with the 30 and figure we'll make up the difference to 45 along the way. So this will be the base, or the pivot point, I guess, would make sense. So let us make a new component. And let us see. What is this going to be? I think this is going to be the mounting plate, I guess, is where I'll start with. Let's grab that, and we can turn off the 2020 for now. We'll come back to that later. And no reason for it not to be round. There's that. So this is going to be a hole in the center where the wow, can't talk this morning. Amazing. This is where the pivot point is going to be. And on other joysticks, you'll often have a plate around the shaft that moves with the shaft and just takes up the extra space so that stuff doesn't fall in between the cracks. So if you imagine, if I extrude this out really quick, 10 is whatever. And then I've got a shaft in here. Just drag it up. So you can see how there's this gap in here because the shaft needs to pivot around this area. This inner hole determines the swing, basically, of how much it can move. So because we have that in there, we have this hole now. And oftentimes what they will do is they will throw another disc on here and extrude that out like this, and that way this disc can move around to cover up the hole. It's larger than the hole so that the hole is never exposed no matter where the shaft goes, and it's tight to the shaft so nothing falls between the shaft and this disc. So that's how it's normally set up. But because our design is going to have the large palm area on top, there's not really a need for us to do that, because that's going to cover up and keep anything from getting inside anyway. So I will not bother putting that disc in. And the other question actually is whether or not I don't make this mounting plate a half hemisphere as well, or, you know, roughly that shape, just because as we pivot around, our shell that's going to be on top that we're holding on to with our hand, that one of those things can go over the edges. It doesn't have to, like, that way it's not impacting on the edges because it's larger. So for a normal joystick, let's swap back over there. Which one was that? Which scene was that? Preview. Where is the joystick? Okay, there it is. So for the joystick, you can see how the top, this shaft just has the ball on top, and therefore no matter how far you turn it, it's actually going to impact on the inside of this hole before anything above that, anything above the shaft, the handle top, hits the mounting plate. So for that reason, it's not a problem. But on ours, if you imagine that being so much bigger, right now, and you know, it could come down lower to begin with, we don't have to have the shaft as high up because our hand is actually covering all of it, right? So there's no way, with a normal joystick, when you grab this ball, if you have this ball lower, then the person's knuckles are actually hitting the mounting plate, which is the problem. We are not going to have that problem, so we can have this shaft be shorter, and that means that, again, we can dome this over so that the joystick rotates around this mounting plate. Now, technically speaking, the mounting plate should be mounted, quote unquote. So we're, you know, kind of changing our definition a little bit, but that is the point, what I'm getting at. So back to Fusione. Push live. There we go. All right. So we are back here. And now we got questions. So for the shaft itself, so there's a couple things, right? One is swing. So I'm just going to really quick, actually, let me just do this in Fusion, because again, having the computer do math for me is a lot easier. Let's look at, and ignore these guys for right now. I'm just going to construction line them so you can make it easier for you to ignore them. So we're assuming this is our joystick shaft right here, right? And let's say we want to go 30 degrees. And again, 30 degrees just being a round number. And by round, I mean, you know, divisible by 360, or 60, 360, yeah, a divisor of 360 is how I should put it. So if 30 degrees is the offset, which again, per the Muse Dash bidirectional controller that I made, that was actually a little bit overkill, I found, but we'll deal with that as we go, especially because the other thing with actual joysticks, and I did not incorporate this into the Muse Dash one, but you can just go ahead and reposition the micro switches so that they're closer or further away from the pivot point to make them, you know, to make the swing greater or less. So one of those things. This 30 is just nominal, and we can adjust it on the bottom side with the micro switches. So that all being said, basically what I was getting at here is I should probably not draw these as lines. Okay, that is just that one. I wasn't sure if that was a but so I'm thinking of using the 5/16 rods that I keep on using because I have them for free at work. Okay, and then if these go off 30 degrees, then basically I just need to make sure that the distance here is 30. There's that. And you should be a right angle is my problem here. Why you're not looking right? Right angle, there we go. So I'm just double checking. Okay, everything seems to be looking correct. So my point being is that, and it's one of those things I could have done math on the on a piece of paper, but I am lazy. So basically, if I take the midpoint here, this is my radius in theory before the shaft clips the edge, which is about 5¼ millimeters, right? So the shaft, when it's off on this angle, the edge of it across this axis right here, again, this being my mounting plate in theory, the pivot point, the top edge of the pivot point, in theory, 5¼ inches. We'll make that 6 just because, you know, why not? So long as we make the radius 6, which would be a 12 millimeter diameter, we should have enough clearance for the stick to swing. Yes, delete. So I will go ahead and unconstruction line these guys, and we'll dimension this out. So we said 12 there. And then this one is kind of whatever for the time being. Basically, I'm probably going to come back here and redimension this after we have the top handheld portion done. It's one of those things. The only reason I'm starting on the mounting plate right now is because I went the 30 from the base. Had I start designing this from the other direction, again, 1.5 million ways to skin a cat. Had I designed this from the palm downwards and then just repositioned everything as I went, or not even repositioned anything because everything was not positioned if they don't exist, but positioned the other pieces relative to the handheld part, as opposed to starting in the middle and positioning the handheld part relative to the pivot point. One of those deals. Wouldn't be running into this situation right now, so that is where we're at right now. The other thing I should mention is I kind of like the aesthetic of the dome-shaped mounting plate. That's going to be, again, as I mentioned, a little bit hard to mount to anything. However, one thing we could do if we didn't want to even deal with that is just make the mounting plate smaller than the palm holding portion. That way it never actually collides because it's outside of the edges. So that is another option we will consider going forward, but I did like the aesthetic of having the mounting plate follow the contours of the palm as it sweeps around. Yeah, sweeps around. So anyway, with all that said, we'll make this 50 millimeters for the time being and extrude it up just so that we have a point of reference. And actually we'll extrude it down. I take it back. So this is going to be minus, and let's call it 6. We'll make it a bit thick for right now. So that's the mounting plate, and now I'm going to want, whoops, do not ground that. I mean, grounding is not horrible, but I mean, it's not going to screw me up immediately at the moment is what I'm trying to say, but I still do not want to deal with it right now. Pivot, let's make the pivot really quick because that is simple enough. And I will use this top mounting plate as my starting point. Reference this hole. Okay. go about 3 millimeters wider is what I'm thinking. And actually, well, all right. So again, there are a bajillion ways of doing this, and I think I will not be doing it this way. So let's hop back here and let's use the revolve tool instead. So let's project the top of that. Okay. And then we are going to go ahead and not what I wanted. Do that, do that, do that, do that. Actually, let's keep that guy on for right now. And then we can do this here, which is 3 millimeters. Yeah. Yeah. No. Actually, so there's a few different things happening here, right? So I said revolve. So that's what I'm going to try to use, but I probably should. I'm just thinking I probably should. Actually, let's go forward in the timeline a little bit. And let me just reproject. See, I wanted to get this hole in here too, is why I stopped. Okay, I guess that is selected. Because I need to, we also need to rather do this. And honestly, it's one of those things I was going to revolve 180, but I guess it makes more sense to not do that. Actually, I should go ahead and throw, actually, I know I keep on saying actually. We will try to find other words to substitute our words. Where's my, oh, there it is. Cannot see. There we go. Axis. And how did that plane get off center? Is this, no, you should be centered. Where's my, why is my mounting plate not on the origin? Am I grabbing another sketch right now? Why can't I delete this quinkadink? Delete? How many quinkadinks are there? Just that one. Okay. Huh. Okay, whichever. I do not know why you were not on origin, but that should solve our issue. Alright, cool. Now let's get back to this. Turn that body, or let's make sure we're in pivot first. Make sure we're in pivot first. Turn the body off. Grab that. Use that axis right there. And there's our hemisphere. Easy. And I have already made a mistake. Okay. This should be 5/16. This should not be the full size. Nice. We're off to a great start today. I guess I will use a square and center it on this. Make those construction lines, make that 5/16 of an inch. And then do this and make that collinear with that, just because I prefer to have it collinear. And now let us try that again. Finish, revolve, boom. Axis is that axis I made through the center of the torus. I don't know if I selected that correctly. There we go. And that should be correct now. Good. Good. Now we can just go ahead and combine-a-roni these guys. Cut. Keep tools. Okay. And then I will go ahead and offset that face because this will be 3D printed and I need a little bit of an offset because my printer is not perfect. And we can go ahead and color this white nylon because in theory it should be something like that. Nylon. We'll make the base plate black plastic. There we go. And now we can move on. I'm gonna go ahead and turn this axis off. Actually, yeah, I can turn the axis off. That's fine. And let's throw the shaft in here. Now the shaft is not. Shaft is kind of not part of the mounting plate assembly, so we will go ahead and make a new component. I'm gonna call this, rather than shaft, because the shaft is going to be connected to the handle and also in theory the actuator, which is, just for the record, let us get this up. In theory they put this little ring at the bottom here, not even a ring but a little bumper at the bottom of the shaft to impact the the micro switches. To some degree it is I guess it helps, you know, it gives you a little bit of extra precision on hitting the micro switches. I don't know if it's 100% necessary, but it definitely does help, so we will also be having that on there. And let's see, the spring we know about. Do we need, yeah, I mean, yeah, I should probably also put a plate underneath the spring just to keep it. See, the reason I wouldn't put a spring underneath the plate is just in theory, I think the spring could go all the way down to the actuator. You know, the actuator and this plate could be one piece. The fact of the matter is that plate, I don't have a good way of, I mean, unless I wanted to, for example, thread these 5/16 rods all the way down and then put a lock nut on the back side of that washer. I'm calling it a washer now, but the plate washer, whatever the heck you want to call it, that retains the spring. I do not have an immediately good way of keeping it in place. I'm guessing that's what these retaining springs are, rings are for. I didn't actually read what these do, so let's take a quick look. Yeah, put some compression and tension in the spring. Yeah, so I guess they do help keep the stuff on the shaft in place, in theory. I don't see them on this, I don't see them on this diagram, but I'm guessing that they do help align that bottom mounting plate. It's one of those things I'm kind of surprised it doesn't slip off. That plate doesn't slip down from the spring. Because I don't have one of these controllers. I don't know how tough that spring is, how much force that spring generates. I did take a quick look at some Amazon sticks just to, or I mean not Amazon sticks, some springs on Amazon for joysticks is what I meant to say. And I do recall seeing some weight mentioned. I just can't remember what it is at this point. And the only reason I did that is because I was looking at these guys, and these guys look maybe a little bit heftier. These two right here look like they might be a little bit heftier than the wire that I have, which is, what's my size wire again? 0.037. So I've got 0.037 is the heftiest I've got here. They look like they might be a bit thicker, but this guy on the corner definitely is not thicker than my wire that I have. So one of those things, I figured I could probably get away with it with the wire I have here, which is why I did not order one of these springs off Amazon. But in theory, in case you were wondering and you wanted, you don't have music wire sitting around for springs, They do sell them on Amazon, so you could just buy one off of Amazon. All right. So, let us. You're going to see a background here in theory, and then I'm going to kick you over here. All right, so we are back here. I guess I'll just call it the shaft assembly is what I'll just call it. Shaft assembly. And this will incorporate everything other than, so this will have the shaft, the knob on the top, quote unquote knob on the top, the spring, the retaining plate, and the actuator is the things that we'll be designing into this portion. So we'll start with the shaft. So let us just use that top of mounting plate as a reference point. We will project out this guy. Let me turn that origin back off. And we can turn the mounting plate off at this point. And regardless of what this is, I want to make sure that this is my 5/16 times 1 inch. And this will be the shaft. And I probably should have made the new component first, but we will cry about that later. Now, the height is a little bit up for debate at the moment because, again, we're going to have some extra swing on this thing anyway. Some extra clearance, I was going to say, because I wasn't going to make the mounting plate intersect with its arc. So, in theory, we can make it a bit shorter than normal. I'm going to start at 50 millimeters and call it like that. I will make this two-sided though. We'll go 50 that way, and then the other direction I'm going to go at least to there, and then maybe another 30. Let's call it another 30 for right now, and then we will actually, no, the spring has to be down here too. The spring, if it's an inch, is about 25 then, and then another 25. So I guess it's going 50 down as well. All right, so there we are, and let's let us see, how do we want to well, I think we may as well, let's open this up really quick and rename you to shaft. I'm thinking we may as well just make the interesting part first. So, new component, handle, handle, knob, what do we want to call this? Yeah, we'll just call it handle, that's fine. Handle this first, handle delay. There we go. Handle's the first thing that came to my mind, so that is what we're going with. And this will be top of shaft right here. Got a name on that guy. And now we can start drawing. And so this is going to be a little bit interesting to draw. The easiest thing, obviously, to draw is a hemisphere. And a hemisphere would technically work, but it's not exactly ergonomical, rather. Ergometric. That's what happens when you use parametric and ergonomical at the same time. So let me take a quick, so actually I don't even need to take a quick look at some pictures because, give me half a second. Getting props. Where is it? Where is it? Where is it? Where is it? Okay. Did I didn't throw that out, did I? I mean, if you told me I threw it out, then I might believe you just because I didn't want to see it anymore. But, oh boy. Ah, there it is. Alright, so that's one. And then that is two, and I will attempt to stretch my other one all the way up on top of the desk. Alright, and we gotta switch to camera now that I am set up. Camera. Alright, here are mice. This is the mouse I used to use. Frankly, just for the record, I don't know if it's just me, but for some reason I have this mouse at home and at work, and I found that when I use it for long periods, I start getting like carpal tunnel. So I don't know that this is the best design, but the point of having all three of these up here. So this is a cheap mouse I bought for my, well, second computer and for the Raspberry Pi that I had set up at one point. Just a quick mouse to plug in really quick to use. But as you can see, they are not exactly circles. They are elongated this way. They tend to have a ridge on this side for the pinky. This guy, not so much. This guy is actually hourglass shaped, more hourglass shaped. This guy, more exaggerated. You can see it really sweeps down and across the side here. So one of those things, ergonomics, in theory, your hand, as I was pointing out earlier, much earlier in the stream, your hand kind of does this, right? These fingers on the side here end up coming in towards the center line more. So one of these deals, in theory, we kind of want a shape like this, you know. At the same time, what I will say is this is a video game controller thing, so if it's not exactly, you know, using my mouse all the time perfectly ergonomic, it maybe does not matter as much, but that is basically what it comes down to. What it comes down to is the trade-off we want to make between having a good fit for the palm and actually getting this project designed today, frankly. So yeah, so the fact of the matter is that I don't mind my current mouse, that was the red one, so much, which is the hourglass one. So we may actually go with more of that hourglass design. Now I am just really quick glancing at it, and it does actually seem to be pretty symmetrical. And hopefully I'm not clicking things on screen and blowing stuff up. I don't think I am, since it's still plugged in. Yeah, I mean, this thing is pretty symmetrical, so the only thing I will say is it does force the ring finger off a little bit too much. So one of these things where, let's see, if I round it up a little bit more. So let me hop back. I know I'm bouncing back and forth here between camera and me talking through this. So right now, right, you can see my ring finger kind of wants to slide off the side here. It doesn't really have a good place to rest on this particular setup, which again, this is the mouse I currently use. I use it all the time. So it's obviously not enough of a problem that I'm going to, you know, throw the mouse out and get a new one. With our controller though, if I make this more dome shape, you can see how that brings my ring finger and my middle finger more in line. So if we dome it up a bit, that kind of takes care of that problem. It kind of brings my ring finger closer to my middle finger naturally, just because I'm curving my hand more. So we can start with that. We can start with a more domed shape and then cut out along the edges is the direction in which I think I will be designing this. Hop back to Fusione. And see, I started from the top again because I always start from the top, and this is going to be another situation where I actually do not want to start from the top. I actually do want to start from the side because, again, I'm going to be doing another hemisphere, and this is useful to have the top thing there because I can just mid-plane it unless that mid-plane came from the shaft. So let me really quick, we are in the shaft right now, so it's a good thing I caught that before I actually completed that sketch. So boom, boom, whoops, that was not the correct plane. There we go, that's the correct plane. Project out that guy, okay. Turn off the shaft, and we can turn off the mounting plate. And then, all right, cool, we do still have the mid. Now for the size, I am just eyeballing this up with my hand, and I'm thinking it's close to 3 inches, I think. At the obviously at the diameter, close to 3 inches. It's going to be smaller than that when you get to the fingers. I think 3 inches is a good starting point, so 75 millimeters. We can make this a construction plane, and then we want to go ahead and catch up fusion, make this collinear, and quinky dink with the edges of the circle. And now we can go ahead and revolve this as well. Again, 1.5 million ways to do this. I'm using revolve a lot today just because I am. But the fact of the matter is that you could have also just made a point and then 180. 180 should be fine, shouldn't it? Why is 180 a problem? Oh, derp. I forgot. When you use revolve, you actually can't. Okay, so the other easy way to do this was to just get a sphere, center it on a point, okay? And then just build it out like that, and then cut the sphere in half. The reason this is not working, for the record, is because the axis intersects, the axis that I'm using intersects this graft, which I forgot is a problem with revolve. So this will work now, and this will do a full 360 anyway, and I don't even need to use the construction over here. It looks like it reverted to being off, so there we go. So there is the basis for our handle. Let me just eyeball this up really quick. So the interesting thing is this may not have been the correct way to go about this. And the reason I'm saying that is, let's turn the camera back on just because we're talking hands. So originally I went like this, and I just kind of measured with my left hand that from finger to finger, I'm like 3 inches, okay? Just from here to here, here to here, about 3 inches is about right. The fact of the matter is that if I make a 3-inch sphere, right, that means that the bottom of the sphere is all the way down here. And it's gonna have a hard time getting its camera there, but you can see where the base of my middle finger is way removed from the center of my palm by quite a bit. We really only want it to be about 1.5, so working off a circle there was a mistake. We will go ahead and resolve that issue. We will come in here. We will ellipse. I'm just going to draw an ellipse here, and then I'll dimension it out in a second. So this one right here, we probably only want to, actually 37.5. Oh no, that's a good point. If I said 1.5, never mind. We're going to be all right. Because I don't have the full diameter in here. Somebody's being a little bit stupid this morning, evidently. Somebody needs to finish his coffee to wake up. All right. I take that back. I was awake at 8 this morning. I technically slept in. I normally wake up at 7. Somebody's already on his second cup of coffee, and it's clearly not enough. So that is the start of it. Again, this, because I'm not an idiot, is all right. Yeah, it's not going to tell you, but half of 3 inches is 1.5, which is what I was looking at. So we should be good there. So now we can come off of the top of shaft, draw this in here, project that guy, and we can make this the hourglass shape that we were talking about before. And I will go ahead and just do one and mirror it over. Let's collapse that, bring that up, and then turn that body off. And again, I will just, actually I guess this will be horizontal, vertical, mid-planed, select it, the bisect, and then we can go ahead and I'm going to just use a spline here. So we will go ahead and start off with that. The question is back to the hand being a funky shape. And let me look at the mouse really quick. Yeah, so the mouse gets deepest further back. So it's about the full 3 inches of the finger. which again, we're not going to be quite like that because we have our sphere more curved than my mouse. My mouse is much flatter than what we're drawing here. But if I say, actually, I take that back. So we actually do want it a little bit further up because our thumb is going to be pretty close to our... Oh, I didn't switch you back off the camera. Welcome back to the camera that I didn't switch you off of. Excellent, excellent, excellent. So, if we're curved this much right, now our thumb is very close to the index finger. This may be a little bit of a problem, but we'll deal with that as it comes up. But the carve out for the thumb is going to be more or less center to our ball right here, as you can see, as opposed to my mouse. My mouse is much flatter like this, and therefore the carve out for the thumb is much further back. It's all the way back here on my mouse. So let's switch you back to Fusion now and get you caught up. Obviously, all I did here was just take a projection of the ball and then cut it in half. Whoops. And like I said, this is going to be more or less centered, it looks like. So we are fine tossing this in here. And tossing this centered on... Actually, you can't actually center that, can you? Okay, I can center this though. I can go here to here, put this parallel. And now that is centered, as you can see. And then it's just a matter of how we want this shaped, how much hourglass we want on this. And we can also do stuff like this, right? We can also, because I'm using a spline line right here, do something like that. And actually, just, so spline lines are a bit of a pain in the butt, because as you can see, you can do one and not the other. So for that reason, I am going to cut it in half, and then we'll mirror this way as well. So you can ignore what's happening on the bottom half right here. And we are going to just cut out this top half. Bodies, distance all. We'll mirror it over top that, and then we'll mirror it across the plane. And that's how we'll go about this. Mirror, features, that guy, select, that guy. Okay. And then we'll mirror both of those guys, boink boink, over the center plate. Whoops. Man, I really wish the right click didn't work like that. Alright, there we go. Now obviously this is a little violent right here. How does that actually look? Nah, I guess that bottom is not as bad, but we can go ahead and just toss these guys in here. Actually, one of those things, since we already have the mirror profiles in here, may as well just add that as a mirror. And it's a matter of how much you really want to go with this. I think I only want to go a little bit, just because any extra we do will interfere with the button that we're going to put in here, the micro switch. So I think I'm going to leave it at that for right now, and then we will compensate later. Alright, so there is that, and now we can go ahead and use the shell command and get ourselves a 2mm wall. Cool, 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 cool. Now we can start building in buttons. Buttons. One of these things where how you design the button kind of depends. So, do I have any around here? These spare parts do not really show it terribly well, so give me half a second. I wish I had better spare buttons around here. Trying to find a good example. I don't particularly want to pull the controller apart. Alright. I think I'm going to draw this instead because I don't have a good example on hand immediately available. So, for these buttons up here, right? Basically, what is going to have to happen, or what should happen rather, is this is going to be a cross section of our controller. I'm going to just use the thumb button as an example. So if this is that part that we just made, okay, this is the cutout for my thumb, and on this wall here is going to be a button, and I'm going to be drawing a half a button here. You can imagine this is half a button. The button is going to need is going to need a lip around it that is on the inside of the plastic to keep it from shooting out this way. And the reason it's shooting out that way is because it's going to want to have a stem that reaches in to hit the micro switch and a spring on that stem to reset it. And that is generally, and not always. So for example, we don't necessarily need a spring. I could skip the spring, to be fair, but even if this is just a stem pushing the micro switch, which again, it's reasonable, it's not a bad thing. And the micro switch, when I say micro switch, we don't even need a full-on micro switch like this, okay? Where's the actual micro switch? So we don't actually need, something like this. We could on the inside of the thing, and most controllers don't even, do this. Most handheld controllers, Xbox controllers, whatnot, don't go for a full micro switch like this. They just use regular little push buttons. Let me grab one of those. I've got this nice and convenient random box of crap right here that I don't organize. So, I would have assumed that I would have some random button thrown in here that I never bothered reorganizing. Turns out I didn't. Turns out that all my buttons are organized right now. Let's check. One of those things, my actual bag of buttons is inside of a big box of components that I'd have to dig through, so I'm hoping to find a button otherwise in one of these easier to access cases. And by button, just for the record, I'm talking momentary switch. That is what, technically speaking, we're talking about. I do not see one in this container, so I guess I will be digging. Alright, time to start digging. Alright. Say hello to my giant's box of components. Random components. There we go. It wasn't too hard. Cool. And not strictly, as you probably saw there, all electrical components. That is all project components. So I had in there, as you might have seen, levels, nickel strips, etc. So let's get this open. This is how basically all your controllers, including your controllers for your remote control, for your television, your controller for your Xbox, they all basically just have these little momentary switches, and then this stem, like I was talking about, just bumps into that, just actuates this button on the top here, and that's how it's built. So one of those things, when I'm saying micro switches, we're probably just going to end up with this guy. The only kind of issue with using these guys in our specific situation is that due to the shape of our controller here, it's not like we can just toss a flat PCB and then plug this into the flat PCB, which is how it normally works. So your normal Xbox controller just has a PCB inside of it. This is sitting on the PCB, and then you obviously just bump into it with this stem that I was telling you about. So that's how it normally works. That is a bit more difficult in our design because our design is funky shaped, right? Which is why, in theory, using a micro switch might be a little bit easier just because it has these mounting holes that we can just match to. But that is the situation as it stands, and something we're going to have to resolve, which makes our life a little bit more complicated. So let's switch back to Fusion. Make sure we actually switch back to Fusion this time. And come in here. So over here again, left-hand side, in theory, because we're catering to mostly right-hand people at the moment, will be the button, the thumb button. So I'll go ahead and take this here, attempt to take here. Okay, so because that curved, I cannot, which does make our life a little bit more difficult. All right, what kind of, can I get a tangent plane? Tangent plane from the inside. Okay, this is going to, all right. We can work with this. I'm just going to do this, and we will project out to the surface is how this is going to work. So I will go ahead and project this surface, and then actually, let's see. So there's two different types of thumb button. There is the base of the thumb button, and then there's the point of the thumb button. One of these deals, it really depends. I kind of like the base of the thumb button better, which would be this plane here, as opposed to the tip of the thumb button, which would be that one there. That's a personal preference thing. Basically, you could do either, and the fact matters is that your tip of your thumb could just reach back to hit this if you find it a little bit awkward. So yeah, I think I am going to put the button on this face. Let's square back up to the body. And I think what I will go ahead and do is I will just make this whole entire profile and just inset it a little bit. So we will go ahead and inset it by, yeah, let's start out with 2 and go from there, just because, again, what we're going to need to do is we're going to need to build that rim around it, as I was saying, to make sure that it stays retained. So let's do that. And yeah, I guess I will just extrude it and then do new component from here, as opposed to backtrack a little bit and create a new component on the fly. Now, from object, and we want to go distance to object, which is that guy, and that is a new component. And then I can hop in here. This is going to be thumb button. We will activate that. And yeah, again, we're going to have to just use this plane here because it's a weird shape. We'll come in here, project that guy out, and we'll toss the, actually, yeah, I guess I'll do it this way. So the other option is just to use the full 2mm that I had, but I think I want to leave some space in here, and we'll see what happens, how it looks. But here's the other thing. So we're going to go distance from object, but we probably want to actually offset this back 0.5 millimeter. That way it's somewhat is that correct direction? Give me a second to turn this handle off so that I got a better idea of where I'm at. And let's just throw 1 millimeter on here. Okay, yeah, that is set back. So, and let's actually select this as well. Attempt to select this as well. There we go. Join. All right, cool. There we go. So this is slightly in the wall now. This retaining portion is slightly in the wall now. And the rest of that will be fine. The rest of that will be at the face of the wall. And now I'm going to want to cut and then offset the faces. Again, 3D printing, not exactly precise. So let's join target body, that body, keep tools, and then we can turn the body back off. and offset some faces to give ourselves some clearance. And I always offset, as I've mentioned before. New. I tend to offset. Well, actually, it depends. Yeah, it really depends. So right now, I'm offsetting these guys. The reason I am not offsetting the body in this case is because I know that I want to. These edges could get weak. Plus, the edges could run into calculation problems inside of Fusion when we butt up against these inside curves here, and the outside curves technically, but we're further away from those ones. So that is the reason why I'm doing the button. I'm offsetting the button rather than the body itself. In some situation, I will offset the body itself, especially because this button is relatively small, so the details we kind of want to preserve, but unfortunately, that's not really a viable approach at this point because we need to stay as far away from these edges as we can. That is why. So now this button gets pieced into here. It will not pop out the side and it will not pop inwards because we'll go ahead and put either a momentary switch or a micro switch right butted up against it so that it does not move. Now, like I said, so technically speaking, let me compose my thoughts really quick. Right now, as is, the amount of swing this thing has determines whether or not it will fall out of this hole. Right now, this hole is keeping it square. So this wall is 2 millimeters. We defined that. And then this lip is 0.5 millimeter. So we have 1.5 millimeters before this front face falls past the recess that we have in here. These micro switches and buttons, I'm pretty sure have less than 1.5 swing, but that is something that we should have considered. So let me just do a quick experiment. I'm gonna pinch the button with my calipers. Well, I mean, heck, we got the camera, may as well use it. So I got my calipers. We're gonna pretend I just turned them on. I'm gonna pinch it like that, right? 0. And then, as you can see, that's 0.3 millimeters. 0.4, let's say. And then it goes back to 0, which means that I know for a fact that it might be hard to see on the camera, I just realized. So we're at 0 right now. I push, get down to 0.33, it's saying right now. Let go, back to 0, so I know that I'm in the correct place on the button. So that button has a 0.3-ish millimeter swing, which is obviously much less than our 1.5 that we have in here to make sure that the button doesn't pop out. This guy, we set up. Try not to depress the button. Depress the button. That is 2.3. That is a full 2.3. So if we ended up using this guy, we need some kind of stop on the inside to prevent the button from, I'm going to switch it back to Fusion. We need some kind of stop to retain this to keep it from going to 2.3, or otherwise we'd need to extrude out around this. So for example, yeah, it's going to be hard to do, but extrude this wall around this recess in order to give it more space to decompress. So those are different things we'd have to keep in mind, but I think for the time being, I'm going to plan to just have the small momentary switch pressed up against the center of this button, and we'll keep it simple. And like I said, this because it's a momentary switch as opposed to the micro switch, I think it makes more sense. I don't know 100% sure, but I imagine it makes more sense to go ahead and just put a stem on it. So again, because we're working with this weird shape on the inside here, I'll just have to come back in here, project out this guy, center a little stem on it, and then extrude it out from the face. We may run into a situation where, because I'm extruding from the face, it is not quite square. I'll take a look at that when it happens. And actually, I want to back up here and make sure that we're in the thumb button, so that I don't, just double checking that I don't have any sketches open, so that our timeline looks good, point being. So I will go ahead and project that out, and we'll get, relatively center here. It's one of those things, center is kind of going to be where it's going to be, 45, and do that. And the user probably won't be able to tell the difference. Maybe they will, but probably will not. And I will just make this so the momentary switch again is what we're looking at using, and that has, whoops, let me zero my calipers back out. That has 3.25-ish face on it. I will just make a straight stem for right now. There is an argument, just for stability purposes, that maybe this should be lofted. So make it larger than 3.25 on the inside of this face, and then loft it out to a point of 3.25. But I am not going to bother with that for the moment. And the reason to be doing this way instead of just pushing the micro switch right up to that button right now is just to give myself a little bit of clearance to mount the micro switch in here. So if I put the micro switch right up against the button, then I gotta kind of piece in another piece to hold it in place, like actually piece it in physically. Whereas this way, by having this stem here, I can go ahead and throw a plate in here. In the design, it will be printed with it, and then mount the momentary switch to the plate. And then if the stem is too long, and I'm trying to put this button in, and the stem is too long, at that point I can then just trim down the stem, just with an X-Acto knife to make it fit. So that is my thought process here. So I'll just go with the 3mm here. And I'm trying to look, yeah. So you see how this follows the contour of the face, right? So we're going to go ahead and I think probably do this. Is just going to be my... Actually, I take it back. We can fix this. So, and by fix it, I mean we can do this a different way to make it easier. So I don't have to just physically hack it down here. And by physically, I mean metaphorically hack it down. Basically, Now see, this would be easier if I could grab a tangent plane off something, but I can't. What would be the best way to go about doing this? I think maybe coming all the way back here. So basically, I need to get a plane in place so that I have something to bump up against, rather. Is this my... Yeah, there's that. Okay, so let's try this. Let us come back up the handle. I'm going to plane through... Can I plane through 3 points? I know I can access perpendicular at point, which may be how I'm going to end up doing this. So I'm going to go ahead and grab the sketch point is what I'm thinking. Let's turn that body off. Oh, face perpendicular at point, not actually through point. Axis through. Face or solid body or surface body. Alright, let's try this one. So I want this... That point. Now what... Not what I wanted, no. yes, I am just kind of spitballing here because oh, there we go. Not what I wanted though. There we go. That's what I wanted. Okay, cool. That is exactly what I wanted. And now we can go ahead and throw a construction plane at an angle through that axis, 90 degrees. And now we can go 2 millimeters minus 2 millimeters, which is our wall thickness. And then I can go another 3 millimeters, let's say, to get to the end of the button stem. I will rename these planes at some point, but that point is not at this moment. And technically speaking, I should have added a little bit extra more for the slip on the back side, but these dimensions are not strictly... Actually, you know what? I should extend it more, though, to give myself some more clearance. So let's just go 5 and call it a day. And that will give me some more clearance to get stuff in and out of here. So we will go ahead and come back over to this, and instead of extruding out a distance, we will extrude to object. Join. And now you can see that is flat. If I look at it from the bottom here, that is flat along that plane. So that's how we went about that one. Took a little bit of work to get there, but we got there. Alrighty. So now we just have the left and right click buttons, and that will be the handle completed. Well, technically speaking, let me Okay, good. That is in thumb button. Scared me for a second there. Let me do this, because the other thing I need to do is put in that shelf, like I said, for the momentary switch to sit on. Yeah, okay. Good. Just want to make sure I was looking at this correctly. So there's that. Actually, I do want to project out the stem. There's the stem. And then we can turn that off. And this does not have to be huge. It just needs to reach, right? So we will come down here like this. And I am going to... So this is the stem right here. The momentary switch is... Actually, do I have a momentary switch in my pile of random miscellaneous? Momentary switch. Let us see. Did I just see? No, I did not. Okay. Momentary switch. Let us check. Checking. There's a micro switch. Do not see it so far. Should have just been under momentary switch. If I didn't file it there, that's a mistake. Let's see in downloaded. Whether I downloaded one. There we go, push button. And let's open that up and see if that is the same dimensions as what I got here. 6 by, well, it should be a square. It should be 6 by 6. So let us inspect the length of, well, I'll expect like this. All right, 6.05, I will take it. So we can go ahead and bring this guy in then. Let me finish this sketch, back up a step, and then insert into current design. Attempt to insert into current design. Proceed. And you did not come in as a group. You jerk faces. Push button. Create group. Alright, cool. So there's that. Let me turn the body back on so that we have a reference here. And let's turn the thumb button on. And we can go ahead and modify a line. You did come in here though, right? Yes, you did come in as a child. Good. We will align you. with that. That makes my life... Oh my goodness, you did not... Alright, push button. And rigid group. Push button. Okay, there we go. You are now a rigid group. And hopefully that got added. It does not look like that got added to group. I wish there was an add to group button. Delete group and expand its contents. Create group. Okay. And now we can come back up here, modify, align that onto the thumb button. Whoops. Don't be so temperamental. Alright, cool. And that gives us a reference now. Excellent. And the fact of the matter is that now this next sketch should actually be... Actually, no, I should redraw this sketch on the appropriate plane. So let me go ahead and take a plane off the back of this guy, and I'm going to offset it by just a quarter, just to give myself a little bit of leeway. Actually, it probably should be... yeah, it should probably be more like 2 millimeters, 1 to 2 millimeters. Let's see where that looks. I was trying to just get past this little bump right here, because these things do not sit completely flat. They have this gap in here because of the legs, because the legs are not going to go completely flat, obviously. So that is why I wanted to offset that. Now we can grab that, project, or I guess intersect is the more correct, what you call it? Intersect. And then we can go ahead and project this micro switch. Yeah, I want to... Yeah, I'm just trying to think which one. Yeah. I guess rather than... it's difficult. It's difficult. The question is whether I want to project or intersect, because the fact of the matter is that I only really need these legs, right? On this guy. Because this plate is just going to be holding this micro switch. Yeah, I think that's what I'm going to do. Okay. Turn the thumb button off. Turn the bodies off. Turn the push button off. And now, like I was saying before, this does not have to be super huge. Yeah, I'll come from the midpoint anyway. It only just has to basically give me room for this micro switch here to sit on. Actually, I could make it so stability is another question, although stability can be built in with struts and whatnot, so it's not as vital. So yeah, I think saving plastic is probably a little bit more important. Attaching it, there's a bunch of different ways to go about this. So I could have this printed in, as I mentioned before. The reason I was not going to is just because by not printing it in, it makes assembly easier. So if I make this pieced in, then assembling it together, I can assemble it in multiple pieces. So I can, let's turn the bodies back on really quick. So I'll have this shell. I can then put the push button in right here, and then I can slide this plate with the momentary switch up and into it. And that's the easiest way to assemble it. If this plate that I'm building right here is part of the shell, that makes my life a little bit easier because I don't have to worry. I can print it all as one piece, and I don't have to worry about getting it pieced in and gluing it in or whatnot. However, I feel like I'm going to piece this in. However, I've got to put this button in at that point, and then I kind of got to flex this to get the momentary switch onto the plate and go from there. So it introduces some hazard that I can avoid if I have this as a separate piece altogether. So that is how I think I will do it. I think I will make this 2 pieces just to avoid the headache. And if this plate ever breaks for some reason, then I can always just print a new plate. Those are the trade-offs and benefits and how I'm going about this. So let's make this construction lines, and then I just want a bounding. Actually, I don't even need these bounding box right here because I can just take it off of the feet. I can just dimension off the feet. Not that side though. Actually, let's do this. Let us do this. Toss that in there. Toss this in here. And then center this on that. And you can go up here. And actually, center was not the correct tool to be using in this situation. I want to grab the center point of this guy and then coinkydink with the center point of that guy. That is actually how I wanted to do it. And then this bottom can just be, you know, let's say 3 millimeters from the bottom, just because it's not really doing much. There we go. And that is above the bottom of here, which is good. That's important. So turn these into construction lines, extrude this out, body. Okay. So what I should do here, finish sketch. Let us back up a second and go a full 4 millimeters. So this is technically 1 plus 3, okay? And the reason I am doing that, and it looks like I lost some of my constraints here. This wasn't intersect, right? So this should still be fine. As this gets taller, right, we get pulled away from the inside wall here. So had I extruded it out right to left in the orientation that we're looking at right now, I would have had a gap between this plate and the top of the wall at the inside corner. If I go left to right, it's getting shorter, so this is going to overlap. So let's go 3 millimeters here. Minus 3 millimeters, rather. So you can see how that overlaps with the wall, and then I can just cut it down to make it fit. You can see how it actually even comes all the way through. So if I had gone the other way, this would have been a gap on the other side instead. I wanted to avoid that. So that is why I'm going this direction. And let me Control Z, because obviously my constraints are off at the moment. Oh, I know why my constraints are off. At this point, those intersects on the push button are not working because we are not intersecting the push button. So I need to come back in here and we will project instead. And I actually don't want that. I want bodies. There we go. And let's look at this. Turn that body off, turn the button off, and now I can fix these. Where exactly these were is kind of irrelevant because I just want nominal. I'm like this is still centered on. My point being is that this is still centered on the button, and all I was doing was centering on the button. I can cut the holes out later. Originally, I was going to cut the holes through right now, but I don't need to. So because I don't need to, it doesn't need to be completely centered. I mean, I don't need to know exactly, rather, where the straight parts are, where the holes are going to be. And everything is now constrained. It looks like everything is now constrained, so let's go ahead and -3 and create a new component. And I'm just looking really quick to make sure that it is still going straight. It is still going straight. So I will go ahead and combine rather, derp. Combine that guy with the body for the handle and keep tools, sure. And this guy will just get removed. Remove. And it's important that you do remove there and not delete, because delete will actually go back and destroy your body from the beginning of time. So that is one of those little obnoxious things that does happen in Fusion, and you just got to be careful of. So let's come in here, grab the front of this rather make sure that we're in our timeline, in our correct timeline. We'll grab the front of face now, and now I can go ahead and intersect the push button. The push button actually should be, whoops, not that though. Do I have a sketch in the way? Sketches. It's funny because sketch is highlighted, but I don't see which one I'm highlighting right now. Alright, let's come to push button, pins, bodies, grab those guys. We'll do it this way because something is clearly getting in my way. I'm not sure what at the moment, and I don't feel like dealing with it. So we'll just avoid it altogether and we won't have the problem. Turn these bodies off, and turn that body off. Just collapsing the search bar a little bit, or the tree a little bit. Yeah, very good. Thank you. Alrighty. Distance all, and one of these things. Obviously, the legs right here. Let's turn the book. They do curve. One of those things where I'm just going to open these holes up a little bit, and then the button will be hot glued in place, so it's not going to be that big of a deal. So I'm just getting the rough opening of the hole where it's going to be sitting. So it's going to be sitting, I believe, approximately this far away from the about 2 millimeters, 1 to 2 millimeters. Actually, I think I did do 1 millimeter. Regardless, it's going to be sitting about this high up off the plate, and then I will just go ahead and open up these holes so that I have plenty of wiggle room, because the button itself is going to be okay, what sketch am I grabbing? Because it keeps on highlighting the sketch right here. You see on the left hand side here, it keeps on highlighting the sketch every time I try to select something. Actually, it looks like that sketch is just glitched out, is what it looks like. So that is just Fusion being silly, I guess. I'm going to rename this to button plate. And let's try this again. Let's try this offset face again. It's not letting me select what I want. Alright, let us escape out. I'm going to hit the save button really quick, see if that solves any of my issues. Do I have anything else on that I might be accidentally clicking? It does look like I am accidentally clicking something. I don't know what though. Body. Okay, now it's not letting me click it. So evidently it glitched out there, and I had to toggle the body off and on in order to make it. Oh, wait, why? Revert position. Don't. Alright, so I've complained about this before. Fusion needs to be fixed so you cannot drag bodies. That is the stupidest freaking feature that I have ever seen in my life. You should not be able to drag bodies in Fusion. We have joints for that. We have the move command. If you wanted to have a free floating movement, you know, just drag and move, then frankly, it's one of those things. Have that as a mode that you can enter, free move mode or something like that, where you can click on components and move them. But this just generically, I'm trying to click things and it's automatically moving them thing is extremely frustrating. And that minus. And I just got to find a good size for this. It's one of those things. I want it big enough, but not so big that it's I have a hard time aligning it in there. So big enough that it's easy and not big enough that it's rattling around. Again, it will be glued in place, but still would like to avoid what I can. Turn this body back on. Let us come in here now. And one of these things here, I should be able to do a tangent plane because this is all right. I cannot do a tangent plane here, but I should be able to do a tangent plane here. I cannot do a tangent plane here. Good bunch of bad. Okay. You know what? We have made a... Why is that button all the way down here? There we go. We have made good progress so far. I am starting to get hungry and probably need some more coffee. So, one of those things. This was going to be a longer than 1 hour design stream anyway. It is a complicated structure that we are designing here. And we have quite a bit designed so far. The only things that we have left to do on the controller is 2 more buttons. Oh, on the handle itself, rather, is 2 more buttons. And then the rest of it, the bottom of it, is just aligning micro switches and putting in some swing adjustment. And then just getting the general look on the bottom here. Now, looking at what we've designed so far, the way I designed this whole entire piece should come down to match the shaft. We'll get that resolved. We'll go ahead and draw that in at some point so that we can line this down. And then once we line that down, then we can determine how much shorter this top part has to be. And then we can also deal with the mounting plate. So those are the steps moving forward the next time we reconvene, which I guess I'll put it tomorrow morning. We'll do this. We'll revisit this tomorrow morning. I want to have some variety in my streams, so I'll do something else later on today. And then tomorrow morning we will look at possibly finishing this up. We are, like I said, quite far. Definitely getting there. So, yeah. Happy with how this gone. Obviously, a little bit of annoyance there at the end. One of those things, you're not yourself without stickers when you're hungry, whatever, however that commercial goes. With the random moving of the components. But beyond that, it was a very enjoyable stream. It got to resolve some issues. For example, getting this offset plane here, figure out how I could go about getting that one. That was fun. And otherwise, the rest of this, frankly, it doesn't look exactly right now, but I promise you, once we get this slid down, it's going to look a lot better and have this mounting plate look a little bit more aesthetically pleasing. I honestly think this is going to turn out to be a really good project. So I am quite excited to finish it, but again, I want to have some variety, so we will revisit this tomorrow morning. As always, thank you guys for watching. I hope you have a great and wonderful day, afternoon, or evening wherever you're at in the world, and I will catch you next time.